Find the first four partial sums and the nth partial sum of the sequence a sub n equals the square root of n minus the square root of the quantity n plus 1. To find the first four partial sum, we would need to know the first four terms in the sequence. Terms, not sum yet. A sub 1 is the square root of 1 minus the square root when n equals 1. 1 plus 1 is 2. A sub 2, which is the second term, the square root of 2 minus the square root of 3. A sub 3, the third term, the square root of 3 minus the square root of 4. And a sub 4 equals the square root of 4 minus the square root of 5. Because when n equals 4, we plug in 4 to n, the square root of 4, and then 4 plus 1 is 5. Once we have the terms, we can find the partial sum. The partial sum using one term only is S sub 1. S sub 1 is A sub 1, which is simply root 1 minus root 2, or 1 minus root 2, because the square root of 1 is 1. S sub 2 is the partial sum using the first two terms, which is A sub 1 plus A sub 2. But A sub 1 is 1 minus root 2, and A sub 2 is root 2 minus root 3. This is 1 minus root 2 plus root 2 minus root 3, but minus root 2 and plus root 2 canceled out, and so we end up with 1 minus root 3. S sub 3 is the partial sum using the first three terms, A sub 1 plus A sub 2 plus A sub 3. But this time, instead of taking the first three terms and add them up, we know that we already have the sum for A sub 1 plus A sub 2. In fact, A sub 1 plus A sub 2 is called S sub 2, and then we simply add A sub 3 to this. But S sub 2, we found it. S sub 2 is 1 minus root 3, and A sub 3 is root 3 minus root 4. Minus root 3 plus root 3 will cancel out and will give us 1 minus root 4. But root 4 is 2, and so 1 minus 2 is negative 1. S sub 4 is the sum of the first four terms, or the sum of the previous three terms, S sub 3 plus A sub 4, where S sub 3 is A sub 1 plus A sub 2 plus A sub 3. But we know that S sub 3 is negative 1, and then we add A sub 4 being root 4 minus root 5, which is negative 1 plus 2 minus root 5. This is 1 minus root 5. Now, the reason why we did not evaluate root 4 because we want to see if there is a pattern here. S sub 1 is 1 minus root 2. Observe that S sub 2 is 1 minus root 3. S sub 3 is 1 minus root 4 before we evaluate it, before we simplify it. S sub 4 is 1 minus root 5, and so we can only guess, we can only speculate that S sub n, all of these sum, S sub 1, S sub 2, S sub 3, S sub 4, have 1 minus, 1 minus, 1 minus, 1 minus, and so S sub n will follow this pattern and have 1 minus. But S sub 1 is 1 minus root 2. S sub 2 is 1 minus root 3. S sub 3 is 1 minus root 4. And S sub 4 is 1 minus root 5. And so S sub n is 1 minus root n plus 1. It is one more than the subscript here. S sub 1 is 1 minus root 2. 2 is 1 more than 1. S sub 2 is 1 minus root 3. 3 is 1 more than 2, and so on. And so we obtain the formula for the nth partial sum, which is simply S sub n equals 1 minus root n plus 1,